Hello friends, myself R.D. Mazen presenting my video on partial differentiation revision part 2. Example number 1. Example number first. If v is equal to r raised to m and r square is equal to x square plus y square plus z square, then prove that dou 2v by dou x square plus dou 2v by dou y square plus dou 2v by dou z square as m into m plus 1 r raised to m minus 2. And to prove this, we draw a tree diagram using the given information. V is a function of r and r is a function of x, y, z, and therefore to determine the second order derivative we have to differentiate this v with respect to x. V is a function of two independent variables and therefore the derivative is partial derivative. Dou v by dou x is equal to differentiating it first with respect to r and then r with respect to x. V is a function of r, one independent variable. Therefore, the derivative is ordinary dv by dr. And chain rule, derivative of r with respect to x is partial derivative dou r by dou x. And therefore, it is equals to differentiating this v with respect to r. As per standard result, it is m r raised to m minus 1 multiplied by dou r by dou x. Again differentiating it with respect to x. Again differentiating with respect to x. The derivative of dou v by dou x with respect to x is dou 2v by dou x square is equal to m constant outside. Differentiate this product by product rule, UV rule. First term is r raised to m minus 1. Derivative of dou r by dou x is dou 2r by dou x square plus second function dou r by dou x, and differentiation of r raised to m minus 1 is m minus 1 r raised to m minus 2. Chain rule, differentiation of r with respect to x is dou r by dou x, and therefore it is equals to m into r raised to m minus 1, or we keep this m outside as it is, r raised to m minus 1 dou 2r by dou x square plus m minus 1 r raised to m minus 2, and dou r by dou x into dou r by dou x, it becomes dou r by dou x square. And then we require these two values, dou r by dou x and dou 2r by dou x square. Given is r square is equal to x square plus y square plus z square. Differentiating this with respect to x, its derivative is 2r, chain rule, dou r by dou x, and is equal to derivative of x square is 2x, y and z are constant term, its derivative is 0, and therefore it gives you, it implies the value of dou r by dou x as x by r to get cancelled. And again differentiating this with respect to x, therefore we get dou 2r by dou x square. Differentiating that x by r by quotient rule formula, it is u by v formula. Therefore r, derivative of x with respect to x is 1 minus x derivative of r dou r by dou x, and whole divided by v square means here r square. Substitute the value of dou r by dou x as x by r, we get r minus x into x by r and whole divided by r square. It is equal to, cross multiplying it, we get r square minus x square divided by r cube. Substituting the value of dou r by dou x and dou 2r by dou x square in this equation, if we call this as equation 1, dou 2v by dou x square is equals to m r raised to m minus 1. The value of dou 2r by dou x square is r square minus x square divided by r cube plus m minus 1 r raised to m minus 2. The value of dou r by dou x is x by r and its square. We call this equation 2. Similarly, we write down the result for dou 2v by dou y square and dou 2v by dou z square. Therefore, similarly, we get dou 2v by dou y square is equal to, for differentiation with respect to x, we are having a term of x. Therefore, when we differentiate with respect to y, we get the term of y. Therefore, it is m into r raised to m minus 1 r square minus y square divided by r cube plus m minus 1 r raised to m minus 2 y by r whole square. We call this equation 3. And dou 2v by dou z square is equals to, replacing x by z, we get m into r raised to m minus 1 r square minus z square divided by r cube plus m minus 1 r raised to m minus 2 multiplied by z by r whole square. We call this equation 4. Square. And then adding equation 2, 3 and 4, we get the addition of left hand side as dou 2v by dou x square plus dou 2v by dou y square plus dou 2v by dou z square is equal to, adding first term of all these three equations, common is m r raised to m minus 1 divided by r cube. Addition of this three term, therefore r square plus r square plus r square, we get 3r square minus x square plus y square plus z square then adding this second term, common is m minus 1 r raised to m minus 2 whole divided by r square, addition of x square plus y square plus z square, x square plus y square plus z square. This is equal to m r raised to m minus 1 divided by r cube multiplied by 3r square, x square plus y square plus z square is nothing but r square, therefore 3r square minus r square plus m minus 1 divided by r square r raised to m minus 2 x square plus y square plus z square is nothing but r square. So that simplifying it, we get m r raised to m minus 1 divided by r cube, 3r square minus r square, we get 2r square plus r square get cancelled, we have m minus 1 r raised to m minus 2, and therefore r square cancelled with r square, remaining as r. Transferring it to numerator, it becomes m r raised to m minus 2 into 2 Therefore, it is 2m plus m minus 1 and r raised to m minus 2. What we can take common from this? From these two terms, we can take common as m and r raised to m minus 2. Remaining is here 2 plus m minus 1, and therefore simplifying it, it is m minus 1 plus 2 we get as m plus 1 into r raised to m minus 2. m plus 1 r raised to m minus 2. Hence proved. We get that required result. Second example, if tan square theta is equal to y by x, then show that dou theta by dou x keeping y constant into dou theta by dou y keeping x constant is equal to minus 1 divided by 4 into x plus y whole square. And therefore, to obtain this, given function is tan square theta is equal to y by x. Taking square root, we get tan theta is equal to root of y by x. Theta is equal to tan inverse of root of y by x. Differentiating this equation 1 with respect to x keeping y constant, we get that derivative as dou theta by dou x with y as a constant term is equal to, we know the derivative of tan inverse as 1 upon 1 plus x square. Here it is 1 plus root of y by x whole square. Apply chain rule. Differentiation of square root is 1 by 2 times root of that term. Again chain rule. Differentiation of y by x with respect to x, derivative of 1 by x is minus 1 by x square, and therefore it becomes minus y by x square. Simplifying it, it is 1 upon 1 plus root of square root, it becomes y by x 1 by 2 times root of y by x into minus y upon x square. It is equal to, cross multiplying it, it becomes x plus y upon x. X goes to numerator, therefore it is x divided by x plus y 1 by 2. 1 upon root of y by x, it becomes root of x by y, and minus y by x square, and therefore 1x get cancelled, we get minus 1 upon 2 times x plus y square root of x by y into y by x. This y we can write down as root y into root y, and this x as root x into root x. One root get cancelled, we get therefore minus 1 by 2 times x plus y and root of y by x is remaining into root of y by x. We call this as equation 2. Differentiation of theta with respect to x keeping y constant, we call that as equation 2. Then differentiating theta with respect to y keeping x constant, therefore dou theta by dou y keeping x constant. Again derivative of tan inverse is 1 upon 1 plus x square. Here it is root of y by x whole square. Chain rule. Differentiation of square root is 1 by 2 times root of y by x into, again applying chain rule, differentiation of y by x with respect to y, this time is derivative is 1 by x. It is 1 upon 1 plus root and its square get cancelled, we get y by x as term, 1 by 2 root of x by y into 1 by x, and therefore we have cross multiply it, we get x divided by x plus y into 1 by 2 root of x by y into 1 by x. X get cancel, we get that value as 1 by 2 1 upon x plus y into root of x by y, and we call this equation 3. Then taking the multiplication of equation 2 by equation 3, we get the required result. Therefore, multiplying these two equations, we get dou theta by dou x, keeping y constant, multiplied by dou theta by dou y, keeping x constant. It is equals to minus 1 by 2 times of x plus y root of y by x multiplied by the second value 1 by 2 therefore we get that product as 1 by 2 into 1 by 2, we get minus 1 by 4. Root get cancelled, root y cancel with this root y, root x cancel with the root x. 1 upon x plus y into x plus y, we get x plus y whole square. Hence the result is proved. That value is minus 1 upon 4 times x plus y whole square. Third example, if u is equal to x into log of xy and another relation x cube plus y cube plus 3xy equal to 0, then find du by dx. Here du by dx is ordinary derivative, means it is the total differentiation of u with respect to x, and to determine this we draw a tree diagram. U is a function of x and y is again function of x, function of function, and we require to obtain the derivative of u with respect to x. It becomes a ordinary derivative. Directly that result is not possible. Therefore what we do, we differentiate u with respect to x first and x with respect to x, then we get differentiation of this u with respect to x, as it is function of two independent variables. That derivative is partial derivative, that is dou u by dou x, and differentiation of x with respect to x is 1 plus differentiate u with respect to y and then y with respect to x, therefore it is dou u by dou y into, as y is a function of one variable, one independent variable, a derivative is ordinary, therefore it is dy by dx. Therefore be very very careful while writing this result. Whenever it is function of more than one independent variable, derivatives are partial derivatives, and when it is function of one variable, the derivative is the ordinary derivative. And then obtaining, we call this equation 1, differentiating u with respect to x, differentiating u with respect to x, keeping y constant, therefore dou u by dou x. Here it is product of two terms of x, therefore applying product rule. First term x, derivative of log is 1 upon xy, chain rule. Differentiation of xy with respect to x is y, constant term outside, and derivative of x is 1. plus second term as it is log of xy, and derivative of x with respect to x is 1, and therefore it is xy upon xy, we get 1 plus log of xy. Then differentiating with respect to y, we get dou u by dou y, keeping x constant. Therefore this x is constant term outside. Differentiation of log 1 upon xy, chain rule. Differentiation of xy with respect to y is x, and therefore it is xy upon x square upon xy. One x get cancelled, we get that value as x by y. I have obtained these two values, and to obtain this dy by dx, and the function of xy is x cube plus y cube plus 3xy is equals to 0 is an implicit relation, and it is, as it is implicit relation, then that dy by dx is given by minus fx upon fy. Partial derivative of f with respect to x divided by partial derivative of f with respect to y, as it is an implicit relation, and therefore it is minus. Differentiating these three terms with respect to x, keeping y constant, derivative of the first term is 3x square, derivative of second term is 0, and derivative of the third term is 3y. Differentiating this with respect to y, keeping x constant, therefore derivative of first term is 0, derivative of second term is 3y square, and differentiation of 3xy with respect to y is 3x. Therefore, substituting the three values in equation 1, we get, therefore, that du by dx is equal to dou u by dou x. The value of dou u by dou x is 1 plus log of xy plus dou u by dou y, that value is x by y, multiplied by dy by dx. The value of dy by dx is, we can cancel this 3 by dividing 3 throughout. It is minus x square plus y divided by y square plus x. Therefore, the final result is du by dx is equal to 1 plus log xy, the sign is minus, x by y multiplied by x square plus y upon y square plus x, as a result or the answer for that term du by dx, or that is the total derivative of that u with respect to x. Therefore, in this video I discussed 3 different examples on partial differentiation. In third part I will discuss some more. If you like my video, please share it as well as subscribe to my channel to receive the notification of my new videos. For that you have to press the bell icon. Thank you. Thanks for watching.